Hello everyone, wish you are doing well. If you are familiar with the electric discharge machining, you know that you need some spark models for your application. When you want to design this spark model, you have to consider these gaps. Which gap? These gaps that are created because of the nature of electric discharge machining. It depends on the voltage and electric current in your applications, but with the traditional spark machine I work, this gap is considered to be 0.07 millimeter or 17 micron. For designing these spark models, in this video I'm going to present a simple method that makes it much more easier for you to design a spark model. Okay, for example, assume that you have this block and you want to machine this block using this spark model. If we assume that there will be no gap and electric discharge machining provides the final cavity for you without any gap, it's so easy. We can do this. We can make a new assembly. Apply the block. Having this auger or whatever you want, make some mates. And after I fully constrained my spark model here, I save the assembly. Then if we assume that there is no gap, it's so easy. We right click on this part, edit part, we go to insert, features, cavity order, and my design component is going to be this. A scale about the component origins, and it's a uniform scale. Then if I save again and open this part, you see the cavity order did its work, what it was supposed to do. But this spark model is going to make a larger cavity due to the nature of electric discharge machining and these gaps. How can I consider these gaps with some easy orders in SolidWorks? It's so easy. You come here, 5, you save it as another name, for example, auger actual size, close the original document. So here we are going to use the surface orders in SolidWorks. To activate surface orders, I right click here and surfaces, activate surfaces. In surfaces, first of all, I'm going to offset surface. I click on offset surface and Control A, select all surfaces. How much? First of all, I set the direction to be in toward the center of the part, not outward. And I can see that those gaps that I previously mentioned, that's 0.07 millimeter in my traditional spark machine, and I click OK. Then after considering this, you see no difference, but you have to do another you have to complete another step, that's cut with surface. Okay, you choose this and you reverse the direction toward the outward, then you click OK. Now if I open the actual the previous file and compare it with this, that's making a new assembly, it will be more visible. If I consider the auger and the actual size one, let me define some mates. This front part should be in the same surface with this part, and for example here this surface with this, and okay, no problem, it's not going to be fully defined. Look, from this surface to this surface we have 362.66 millimeter, but here 362.8 millimeter. If I make a section, everything is more visible. Then the new part is offsetted. So, but that's not the final step. I have to do some other works. If we see here, it is considered whole part as a body, but make some problem when you are going to add other modifications and use other features. So what I'm going to do, I'm going to file, save as, a step file. I'll save it as a step file, then I'll close it. Here, this step file represents the part that I had before, and if I look at the bodies, it is made of two bodies. What I'm going to save as, I save it as a solid part again, but add the modified, excuse me, at the end. Then I'm going to turn these two, right click, combine. I'll add them together. Now I have a solid body. Then you can do other work, for example make a tapped hole at the end. Whatever work you want to do, it depends on your design. then you see that there will be no problem and everything is alright. Now if I add a new assembly, make a new assembly, and consider my block here, excuse me, and again have the actual size of the auger here. That's not going to happen when you are electric discharging machining. It was because of my part. I didn't consider the proper part for this tutorial, but no problem. I'm going to select this face and this, made them select this face and this face, then advance, I click OK. Now it's going to be the part you are going to design for your spark model, because the gaps are considered right now. Look, if I do a section, if I make a section, you see all those gaps are considered here. And if I measure it, the distance between two lines are 0.07 millimeter. It is the gap that I mentioned in the start of the video. Okay, it's so important, especially when you are going to design a part that it requires precise dimensions and geometry, and it depends on your machine and your application. It may varies through different applications in electric discharge machining, but you can easily obtain it doing a simple examination. It's the same for other sections too. If I do this section, it doesn't matter. Again, measure, zoom somewhere, the distance between these two lines, I see that's 0.07 millimeter. That's the gap I'm going to consider for my spark models. I hope you enjoyed this video and using this method for designing your spark models. If you are designing some high precision parts, you can first obtain this gap using a simple examination with your spark machine, then apply it for future spark models. Wish you all the best. Wish you have a good time. Goodbye.